Hi guys, my name is Anna Risina and today I will be your expert on this track. It's a great honor for me to introduce our speaker. It is Julie Lerman. She was an MVP for ages. She's an expert in entity framework. She has started working with entity framework since its first release. And Julie, what our talk is about today?
I'm going to look at Entity Framework Course 6, which is going to be released in a few weeks, and look at some of the more interesting features in EF Core 6.
So, and due to this talk is going to be about 16 minutes, and it's going to be long and extremely interesting. Let's move to the talk itself.
Okay, thanks, Anya. All right, so I've titled the talk Working on the Bucket List because the Entity Framework team has been working, they're finally getting to those really interesting things that they've been wanting to get to and working on a list that was created from the community, from a survey. And I want to make sure everybody's aligned with where we are with .NET. So and Entity Framework Core, so it does sync up with .NET releases. So Entity Framework Core 5 released with .NET 5 a year ago, and EF Core 6 will release with .NET 6 next month, and this is going to be both of these will have long-term support. It's also useful to know that they're planning on releasing Microsoft is planning on releasing .NET 7 in the next year, and so we can assume perhaps that Entity Framework Core 7 will come along with that. And speaking of long-term support, it's also good to know that EF Core 5 support, EF Core 5 is not LTS, so its support ends in May of next year. And even EF Core 3.1 support, which was long-term support, ends at the end of next year. So it's good to move into the next versions of certainly the long-term support. So what I'm going to cover in this session is really the changes that are really high impact. So I'm going to do a bunch of demos related to those. And so, query and startup performance, deploying migration support for doing better DevOps with migrations, and temporal tables, which is something I'd never even known about before, but it's really a big deal, it turns out. And some other things I'll do demos on. And then after that, I'm just going to run through some other things that I think are interesting, but we're not going to spend time on the demos. So first up, and most important to almost everybody, is performance. So specifically in EF Core 6, they really hammered on query performance. And what they did was, EF Core doesn't compete. They don't compete with Dapper. I mean, it's, an ecosystem and a lot of people use both. But Dapper does have really great performance. So they kind of focused on, let's see if we can achieve similar performance as Dapper for queries. And in the end, with all the work that they've done, when they used the Tech and Power Fortunes benchmark, which is a really industry standard that specifies how your application should work in order to do the benchmarks. So everybody's on the same page and comparing the same things. And looking at the full stack, not just EF Core 6, but .NET 6, an ASP.NET Core application using EF Core 6, the performance increased by 70% using these benchmarks compared to the EF Core 5.0. EF Core 6 itself is from like really lab tested benchmarking. They came up with a number that says it's 31% faster in executing queries. So this, I'm going to focus on the queries. So a little more details about the Tech and Power Fortunes test and where EF Core is making these improvements. So the top row shows how many iterations per second, how many times they could run this per second in EF5 with .NET 5. So the first thing they had to do actually was they had to improve on their tests and make the tests align more with the requirements for the benchmark, for the Fortune's benchmark. And in doing that, they already saw a 30% increase. Then by moving from .NET 5 to .NET 6, that increase helped them another 10%. And then tweaks in the changes in the APIs to EF Core for EF Core 6 added another 30-ish percent. So that's where they get the 70.4. Now, if you were to look at Tech Empower right now, they only have publicly the round 20 benchmark. So you're not going to see any of this yet because that was back in February. So it was EF Core 5. But there is a way to see the previews, and those get updated frequently. So there's a link there if you want to see the difference between like the ASP.NET Core with EF Core application that they're using for the benchmark. With EF Core 5, it's way down there, like in the 30s rank. With EF Core 6 and .NET 6, it's really close to the top, which is pretty cool. So some interesting things they did in the APIs to make the performance better for EF cores. They really focused, one thing they focused on was pooling and recycling. So we already have pooling on the DB context. So they added in additional logic for pooling the connections and commands and other internal objects. They also made, and there's a whole blog post where you can find out all about this. Well, there's a blog post and there's a link here where you can read the details a lot more than just these three things of all the things that they did in the APIs and how they impacted the speed. So another was about how they're looking for logging and interception. So they were doing that like continually, and now they're doing it in a more intelligent way, right? It's still giving you the information that you want, but they're not wasting time looking for that stuff while the query is trying to do its logic also. Most of this stuff is just happening under the covers. You don't even need to know about it. But another interesting thing is that you can opt out of thread safety checks now. So you can use them by default when you're debugging and testing. But then when you know everything's okay, you can opt out of them for your production deployment, and then save some speed there. An important thing to know about this is that for EF Core 6, they really focused on non-tracking queries. So they did a lot of work there, and that's the numbers that we're looking at, queries that aren't being continuously tracked, like in web apps, right? You're not going to, if you're retrieving data in a web application, you're not going to keep tracking it because the request and everything disappears. But they do plan to now tackle EF Core, tackle tracked queries in EF Core 7. So the things that they learned now, they're going to be able to apply there. So I have a demo. I'm not going to run it because it's, I'll show it to you. It's using benchmark.net, which is a really, really great way of making sure that when you're trying to do benchmarking, it handles warm-up times and repetition and throws out outliers, et cetera. So I just running the demos takes because it does all that stuff and it iterates many, many times. It takes a little bit of time to run the demos to get the actual results. So I just want to show you what I'm doing in the demo, and all of this stuff will be on GitHub, so you can look. So this is, again, the demo is built to focus on query execution and materialization of objects. So I'm doing all kinds of things to make sure spinning up the context, any of that work to be done with a context. I'm getting that out of the way. So, for example, I'm pre-compiling the two different queries as enumerables, and also, so one query just grabs one record, and the other query grabs 1,000 records. And then I'm also making sure I'm taking advantage of pooling. So I'm creating a pooled DB context factory. And I'm definitely making sure that I'm using no tracking query for anything done with this context. And I am opting out of the thread safety checks. So I'm doing all of these things to reduce, and enable the benchmark to just focus on what's going on with the query and the materialization. So here's the first benchmark, which creates a context from the pooling factory and then passes it into that query that gets 1,000 rows, and then it just returns zero. So we have something. And the second one is the one that just gets one row. So that runs a lot of stuff actually, because it does like a whole bunch of iterations for warming up and et cetera, et cetera. So there's a lot going on there. And I also did the same thing. This one targets Entity Framework Core 6, and it's using .NET 6. And I have another project in here that uses targets EF Core 5, but it does target .NET 6, so you can really see the difference between EF Core 5 and EF Core 6, not having the improvements in .NET 6 itself also impacting it. So I've run these a number of times, but I did it again this morning. Oh, that's strange. Yeah, it might be. Okay. Yeah, yeah. Okay. So the doing those tests, I ran them again this morning, and just looking at this, you can see when I was running the EF Core 5 version of the tests, it took about twice as long as the EF Core 6 version. Now that's with the 1,000 rows, not the one row. The one row just isn't enough work for it to make a huge difference. So it's still pretty impressive. And then being able to look at the tech and power benchmarks is even more impressive, right? I call this my backyard test, right? Because it's not like a lab setup, it's just my computer. So that's the query performance. That really is going to be something that is huge for people because, we've been kind of complaining about it for a long time when we look at especially other ORMs or doing direct data access, right? And not being able not sometimes not being able to justify using Entity Framework if it's creating a lot of problems in performance. So that's really, really a huge thing. Okay, so maybe the internet performance will be better as we're talking about performance with EF Core 6. So, in addition to the improvements on query performance, there's also an important thing the team has done to help with startup performance. And that's when you have a model that, at runtime, Entity Framework has to read the model and understand everything about the model. And if you have a really large model, that definitely impacts the startup performance. Now, if you've got a web application, like it's just that first time, right? That first time that it's being used that you're paying that price. But it's still, if you're have to spin up more instances of your website, whether maybe in containers or something like that. Each one of those containers, every time you're starting up a new one, you're paying this price. So what the team has come up with is a way to create pre-compiled models, and we had something like this back in EF6. This is a lot different. But so maybe this is a parity thing, right? That we now have the ability to pre-compile models again because we haven't been able to with EF Core. So first, I want to talk about a demo that does a really, really good job of demonstrating this. Um, it was one by Arthur Vickers. You can download it from his GitHub account. He also demonstrated this on one of the EF Core stand-ups. I'm not going to because it is it's a convoluted looking thing because he had to create all of these entity types and all of these properties, but it's a really huge complex model. And so he ran this before and after, so without precompiling, and on the time to get to the first query when you're just letting EF Core build that model on the fly. So that was about 1.8 seconds. And then again with this really complicated model, he got that down to 157 milliseconds. So more than a 10 times more than 10 times faster. So I'm not going to run that demo because it's a lot to look at because of all the things going into this model. But what I will do is I'm going to show you in a much simpler demo, a much simpler project, how to do the compilation and what it means, what it does to your code. But I'm going to do it in a bit of code that's just a little easier on the eye. So I just have to keep switching branches to get from one to another of these, and then I have to, just to be safe, .NET clean and .NET, yeah, build. It's restored, it's building. This is definitely there. This is just an issue of it just trying to catch up. But I know that this is really there and it builds just fine. So I'm not going to worry about that warning. Visual Studio Code is a little confused. So the way we compile a model, so I'll just show you, I just have a very, very simple model here. I've got two classes and I have a pretty simple, right, context. There's really nothing going on here. So it's not complicated like Arthur's, but we can still take advantage of the compilation. It won't save much time because it doesn't really have to do much work here, but I just want you to see how it works. So in the CLI, we have a new method, .NET EF DB context optimize. So that's the new method, optimize. And this is going to build the models. All right, so what this is going to do is normally when any framework core builds the model in memory at runtime, it has to look in a lot of places, right? It looks at the DB context, sees what classes are involved, looks at those classes, uses its conventions to make its determination about what the schema would be. Then it goes back and looks at the configurations and additional mappings that you might be adding into the context, right? So it's going all over the place, pulling all of this information together. So what the optimize has done was it's streamlined and just collected all the information that EF Core needs to know about everything in that model all in one place. So it creates classes for each one of the entities in the model. So like if we were looking at Arthur's, there would be hundreds and hundreds of these. And they would be more complex. So it's just redefining it. And everything you need to know about mapping a person is right here, including these annotations that are specific to model compilation. So here's one where it's saying the table name is going to be people. Right, so address entity type, it's doing the same thing, everything you need to know about it. Now there's a relationship between entity and person. So you can see down here in that compiled class, the compiled class, it's got some additional information about the relationship. So everything it needs to know about the entities is in one place. And there's also this model builder, which tells EF Core how to build the model from the entity types that are in this compiled models folder. By the way, you can overwrite the name of the compiled models folder, little things like that. So there's ways to tweak the command. And then there's also the model itself, which is just pretty simplistic, right? It's simple stuff. And it still will read some information out of the context. But then the other important thing to do is now we need to tell the context to use the precompiled model instead of do its own. Now, IntelliSense is going to help me because because Visual Studio Code or OmniSharp is a little confused. So I want the people context model, and people context model. I'm wanting to depend on IntelliSense instance. So there was an instance property in there, and that's the key to doing it. Now I'm gonna save this. I'm just gonna close and reopen this really quickly. Maybe not as quickly as I'd like to. There, I just wanted that problem, that not real problem, to go away. So that problem is gone. The compiler is happy again. So now I just need to let it know where to find this, what namespace to find it in. It's in the compiled demos namespace. Okay, so now that's all working. So now I'm going to run this. I'm going to put just a couple of breakpoints inside the new classes just so you can see we're definitely hitting them now. Initialize. Okay, and then I'll go ahead and debug this so that you can see. Now here we're not going to do any benchmarking or anything. Like the interesting benchmark results were from the details I shared about Arthur's demos. This is just seeing that it's actually doing its thing. So now it's inside that precompiled address entity type. And I thought I put another breakpoint in there. Anyway, so that's essentially how it's working, right? It's just created all of these compiled model types that we can use. It's compiled into your application, and then we just tell, oh, there's the database that got created. It just it compiles it there, and we just need to make sure that the DB context knows how to use it. So you would not do this. I don't see any reason to do this when you have a tiny little model like this one, but when you have a big model, you can really see a big impact in the difference there. So my clever use of Git to keep track of all the different demos I'm doing here. Okay, so this is just a little reminder. So we do .NET EFDB context optimize, or if you're in PowerShell and Visual Studio, optimize -db context, and then to be sure you use that model. Make sure that the DB context is using the correct model. So now we're on to not a performance improvement, but for DevOps, people doing DevOps, they're going to like this a lot. This is a DevOps-friendly migrations, and the feature is called migrations bundles. So you can actually bundle up your migrations and deploy them a lot more easily than we can do that now. So what problem is this solving? If you've got web-based applications, getting your migrations in there is really not something that's, it's not the easiest thing to do. A lot of people want to just run them in the application startup, and that's a big no-no, or a niet. um, and I would like to say, by the way, I did study Russian for 1 year about 40 years ago. So I don't remember much. And I was a Russian history major in college, but it was a long time ago. Anyway, so this is actually a big problem, because imagine if you have multiple instances of your app starting. You got more users, you're spinning up new containers, and the app is starting, and each one of those containers is trying to run the migrations, and you might have race conditions, and that could create real chaos. So it is not recommended to do that in, certainly a normal production scenario. So what a lot of us have resorted to was taking advantage of the fact that we can generate scripts from migrations and then feed those into, some tool, one of the many SQL Server tools, or I really like using Flyway DB. So if I'm using containers, I just spin up the Flyway container and it executes whatever scripts that need to be done to apply, and boom, I'm out, and that's easy. But people really wanted to have an easier way of doing this, at least, if you're getting started, right? But still, it's a totally production worthy solution, this bundled migrations. So that's new in EF Core. So to do the migrations, that really all you have to do, it's a command, right? So in the CLI, it's .NET EF migrations bundle, or in PowerShell, it's bundle dash migration. You can it generally by default it outputs a file called EF bundle. If you're on Windows, it's an .exe. If you're on Mac, it doesn't have an extension, or Linux, it doesn't have an extension. And you can change the name of what that file output is. You can also use a self-contained parameter. So once you have EF bundle, you can run it anywhere that you have .NET, right? So maybe you have a Docker container, for your CI/CD or something, and you've got a container that has .NET in it, and you can run it. But you can also create a self-contained version of this file, so you'll have no dependency on .NET at all to make that run. .NET will be built into the file. The file's a lot bigger. And then there's a force parameter, which I use a lot when I'm doing demos, that makes sure that it won't say, "Oh, EF bundle already exists," right? Like, it'll just overwrite it. When you run EF bundle, you can, if like in my demo, the connection string is available, so it will just run. But you can pass in a connection string, and it's also idempotent, which is really cool. So flipping over to this demo, I want to show you how the bundles work. So again, I have to just do a little cleanup here as I go from branch to branch. Now, one thing I want to mention, I may or may not hit this. There's an issue right now with the most recent version of the C# extension, and we'll see if this, sometimes it runs, sometimes it doesn't, and I have to disable the C# extension, or I can open up the Visual Studio Developer command, and it works just fine there. So it's just building, clean and build. Okay, so we'll see if that is working. So I already have my migrations in here. So I just have an init migration. There's really not much going on here. It's the same kind of simple model that we saw before, a person, an address, and not much going on in here, except in the context, for the sake of this demo, I do have a shadow property. And the shadow property is just to add a last updated field. So every time I save changes, there's an event that gets triggered, update shadow properties, and I'll just update that. So that's just for the sake of running this code. So I will do .NET. EF, I keep forgetting EF, migrations bundle. Now let's see if it works. Oh, .NET EF migrations bundle. Live coding is fun. Okay, so let's see if it's going to work or not. Sometimes it's working, sometimes it's not, and I know exactly the message. Oh, yes, it worked. But then we do have these OmniSharp is going a little crazy with its messages. So it created the bundle. There it is, EF bundle, right? You can't look inside of it. I've actually requested in GitHub if they could give us a way of seeing what's inside the bundle. So I'm just going to go ahead and run it. And you have to run it with a window, run it with a path. Yeah, well, that's weird looking. Okay. Bundle, and you'll see the message that it applied that migration. And also, this actually is running just the database update command. So it created the update for me also, and then created the database and then applied the command. So I'm just going to look at the database. This is SQLite, and I'm using an extension to look at SQLite. And you can see if we look at the table, there's a lot of moving parts here. So you can see that one was applied. So now I just want to show you the item potency of this. So if I had to make a change to my model, so I'll go ahead and add a new string called middle. And then I have to create a new migration. .NET EF migrations, spelling, add middle. Okay, there's the middle migration. So now I'm going to create a new, I'm just getting some screen real estate here, a new bundle. So just boop. This time I'm going to use force because I don't need to keep the original bundle. So I'm just going to have it be the same name. So I'm just going to overwrite that file. Okay, now I'm going to apply that. I'm going to run the bundle, right? So this is demoing it. I'm doing it all inside of the project. So I have all the assets ready, right? So I'm not going through the process of, okay, now we're going to deploy this executable, to the cloud, to wherever my app is running and run it. So that's like, phase 2. I just want you to see it working. So run EF bundle. And I have 2 migrations, and this time it said it applied the migration middle. So one more time, I'm going to remember those timestamps I told you about. So I'm going to run the application again. Can I make this stop? OmniSharp stop. Okay, so that's run. And if I'm just going to refresh the database. And this time I'm going to open up the people table. That was not the goal. That's okay. Oh, I didn't run it twice. So what I wanted you to see was that the original data was still there. I'm not gonna bother redoing it. I meant to run it the first time around also. So the point of the second demo is that it is idempotent, right? All of the migrations are in the bundle, but it determined that the first migration had already been run, so it only applied the second migration, and also I didn't lose. Had I created data in advance, I wouldn't have lost that data. So being able to do that, being able to create those bundles and get them into your DevOps pipeline, put them into CI/CD, toss them into containers to run them. And maybe what I'll do, since we do have some time afterwards, we'll play a little more with that. Look at uh, creating one that has .NET built right into it. So important. I want to just undo my changes so I can easily move from one to the next. So that's migration bundles. The next thing I want to show you is support for temporal tables. Now, I mentioned earlier, I did not even know about temporal tables. I'm not a DBA, right? I'm programming. I'm just working in the code and accessing the database. And none of my clients had ever come to me and said, "Oh, we need temporal table support," right? I just was totally unaware of it. So, of course, I had to see, in order to understand this feature change, I had to learn a little bit about temporal tables also. So I want to make sure, if you're like me, hey, I got over 30 years of programming experience and did not know about these. But now that I understand them, they're pretty cool. So temporal tables let you keep track of the state of data in your database as it changes. And it's a SQL, I think it's a specification for SQL, not a standard. And so not every SQL database implements it, and they have their own ways of implementing it. So this is looking at SQL Server, and the view I'm using SQL Server Management Studio to look at that. So here's a temporal table. SQL Server tags it as system versioned. So the system, the database, is going to be responsible for keeping track of that past state. And what it does is every time you make a change, it tucks it away into this subtable. Like, I don't even like this, a history table, but it's within it's part of the people table. So the people table has its columns, ID, first name, etc. Also, important to this is there's columns to track when the particular state of the data is relevant. So it's start and end date. So when you create new data or update data, the start date will be the moment that was added or updated in the database. And the end date will be just forever, right? Then when you make a change, it tucks the original version, including the start and end date, into that history table, except it changes the end date to the moment in time that you made the change. And then the new version, the current version that's in the regular part of the table, I don't know if there maybe is a better term for that. Its start is now the moment that you made that change, and its end is never ending in in the future. Right? So that's what temporal tables are. And in order to work with those temporal tables, SQL Server, T-SQL and the different SQL languages have query methods for specifically saying, I want to query, I want to see what the data looked like at a certain point in time. I do want to point out this is not event sourcing, right? We're not tracking the events. We're just literally keeping history of the state of the data. And so the database has a number of different ways of getting views on that historical data if you want to see different date ranges or whatever. So I didn't know this, right? But it's a really important feature to a lot of people, and they have been asking Entity Framework team for quite a while to support it inside of Entity Framework. And So they did. There's a number of pieces that they added to the APIs to support this. First of all, there's a new table mapping called isTemporal, and that's all you need to do. Just say, this table is temporal. And then in the migrations, now it writes its own migrations, but when you create the migrations, it will add the start and end columns for you. And in SQL Server, they have to be date time too, by the way. And it also has all these annotations. Now you saw some annotations earlier when we were looking at migration files. So there's also annotations for temporal tables. And then when it generates the SQL, it knows how to generate the SQL that will create a temporal table. So I will quickly look at the temporal table branch. And I'm just going to show you what these assets look like. So let me just close all this stuff first. Okay. Oh, please. So I just have in my domain models, again, these are really simple, but what I want you to notice is there's nothing here about those date time fields, right? They are not in my domain objects. It's just for the database. So, and it's also just a good reminder that we don't have to keep track of those date times. SQL Server does all of that work. It does all of that work of updating the time stamps and moving data over to the history table. So I don't have anything about this. I don't need to know anything about this when I'm working with my domain. In the context, I just have, and again, I guess I have to restore and build and whatever to make the squigglies go away, but this is all fine. So I'm just using that mapping that says is temporal, and then the migrations that it created have all of that special code for temporal. So down here, look, it automatically created those two properties, those two columns. And then there's all kinds of annotations here that are related to temporal. Okay, so there's that. And then here's the SQL that's getting generated from that migration. So you can see it's got this declare history table, and then there's all kinds of information here on the date time too, right? And it's hidden; it's not null, and it's also flagging those as those are the columns that are related to system time. So all of that stuff just happens magically for us because the migrations take care of it. So what I will do is I will run this. Oh, come on. It needs to .NET build. I know. Build's restoring for me. Don't worry about it. So .NET run. And here you can see in the insert, it's not inserting anything related to those periods start and period end, right? Again, SQL Server's handling that for us. So what .NET Run did for me was it deleted and recreated this table. So I created this table, and you can see that they all have the same start and end. And end is like, never, never ending, but the start is the same. So if I were to go ahead and update this, update one of the rows, notice that if I just do a regular query, there's the new information, Jones, the new last name is Jones. And notice that it started you know, 45 seconds later than the others, right? So that's the new version. Now I'm going to do a raw temporal query, and I just want to say something that was, after the first time I created it and before I made the change. Right? So now I can see at that moment in time, it pulled it out of the history table. At that moment in time, the last name was Jetson, right? So Entity Framework now has methods such as temporal as of, right? So I could change the audit date to the one that we just did to emulate the query that I just did. But this method, temporal as of, will then take in the date and it will create the right T-SQL to go ahead and query the database. So that's actually really, really cool. If you've been using temporal tables, that might be pretty interesting to you. So the last thing I want to show you is about bulk configurations. So this also is, here's, just so you know, here's the other query methods that you can use for temporal tables. So it's not just as of. So bulk conventions and conversions. I'm so happy to have these. So we have a new method called configure conventions. And in there, we can specify mappings, conventional mappings for specific types and also to do value conversions. And what's important about this is we never were able to do this in a bulk way before. We had to do it one property at a time, especially if you've ever used any of the conversions, the type conversions. We had to do them one property at a time. So if I have an address type enum and I always want to store that as a string because by default it will get stored as an int, I would have to specify that for every property in every class that has an address type enum. And now I can just say, anytime you see an address type enum, store it as a string. And this is also nice for the custom versions of type conversion. So I like to use the example of color because that's not specified. So to do a bulk one, the only thing that you need to know about custom conversions in EF Core, well, this came in EF Core 2. So since then, you can do one on the fly. You can do a custom conversion for a property, right? You could only do it for a property. And you could do that on the fly by the has conversion method and just saying, when it's headed to the database, take the color structure, the color struct, and convert it, use its toString, because so color has a toString method, right? So just use its toString method and then take the results of that, pass that into the database. That would be a string. And when you're reading it from the DB, you're going to get a string. And when the string comes back, use the colors from name method to convert the string back into a struct. So that's nice to do that on the fly. Unfortunately, you can't do that with the bulk conversion. And the reason is because that won't work with the precompiled models. They won't be able to read that. So I thought that was interesting. I was like, why can't I do this? What am I doing wrong? And somebody from the team explained that to me. So that ties that together. So this is just an example. So what you have to do is you do have to build a custom converter class. And again, we've had this capability since EF Core 2. So you can see that in the slides. You can see that in the demos if you want to see how that works. So there's a couple of the things I want to run through that I think are really interesting for those of you who use Cosmos DB or a document database, right? The Entity Framework core team works on the Cosmos DB provider. And they've done a lot of work, in the same way that we have a relational API, right? A NuGet package for relational databases, and then the different relational databases use that. They've done that work also. So there's like I haven't there's a common API for document DB. So the improvements they've made, we're seeing it as a result in the Cosmos DB provider, but they're really done at a lower level so that it'll be easier to have other document DB providers take advantage of that. So there's a lot of improvements there this time around for Cosmos DB. One I really love is that it implicitly understands ownership, right? In a relational database, it doesn't even have the concept. And so Entity Framework has to do all kinds of weird stuff to make like our value objects or complex types, make them store properly, go in and out of the database. And so we have the owns one and owns many mapping that we've used. But if you're using the Cosmos DB provider, it'll say, well, obviously, this name with Andrei Svirid, who's on the team, this name is, a subdocument. So you don't have to map it, right? It just understands that. And another, it understands it and then maps, stores it that way in the JSON, creates the document that way. And additionally, if you have related objects, so entities with IDs, like this address that I'm showing here, if it does not have a DB set, then the Cosmos DB provider will also implicitly understand that that should be a subdocument and it will store it that way. So I think that's pretty cool. If you're using Cosmos DB and you're reading the logs right now, you're not seeing a lot of detail. So they've added a lot more logging events into the logging information. So you can see what kind of event is happening. They even tell you how long, not only how long it took, but the RUs that it cost to perform that. And also we can see that the container and the partition that are being used. So that's really helpful. Another thing I really like, and this is, I forgot to point out, I've got these DDD friendly little icons in the corner there for those of you who are fans like me of domain driven design. So this is, again, something you can't do, a relational database can't do, but a document database can, which is to store collections or dictionaries of primitives. So it's smart enough to do that now. Like, again, the Cosmos provider will do that. If you try to run this code where, I have this list of strings or even a dictionary of strings, and I, try to run that, SQL Server provider will just blow up and say, no, you can't do that. But this Cosmos understands how to store that data, so the provider knows how to push that data through. So for those of you who've been looking for more parity with Entity Framework 6 for your group by queries, there's definitely some goodies in here for you too. I tend not to be a fan of group by just because it's so hard to write. It's complicated, and I'll usually let somebody else do it. But actually, I had to do a lot of re-educating in order to dig into this new support. So the couple of things that you'll find with group by now is that if you're including related data in your grouping, normally you wouldn't be able to see inside of that related data, but now you can access its properties. So you can see I'm querying people, I'm including addresses, I'm still grouping by a property in people, but now I can access properties of street, of the address, so the street property of the address as an example. So that's possible. What's really nice and important is now if you can actually, in group by, you can get back actual objects. Like before, we were only able to, by default, it is only able to give back aggregates, return aggregates. And if you wanted actual data, actual objects, then you had to call as enumerable, and you're essentially um, executing it and then doing the grouping on the client side. That was up until now.
Julie, Julie,
Yes.
sorry. Just kind reminder that we have 3 minutes and a half.
Yep. Thanks. So with EF Core 6, now you have the ability to return. You don't have to use as enumerable in order to get back the objects. So not only is that nice so you can see the objects, but it gives us, because of this, we have some new interesting capabilities. One is you can use first or default in retrieving those objects, right? All of this will happen on the server now, not on the client. And something, again, bucket list. People have been asking for this a lot, to be able to get back the top 5 or the top 10 or the, top 2 or whatever. Well, now that EF Core 6 lets us get back objects, it also understands these, take methods. And so we can also get top and back out of groupings. So that's really, really cool. Just a couple quick notes. Minimal APIs is a big new thing in .NET 6 and ASP.NET Core apps. And so a lot of stuff is hidden because of the minimal API, but Entity Framework does have support for it, so you can dig in and add services. So you can do dependency injection. So that's just a quick note. And also, it allows. It's a little more flexible for doing free text search, free text or contains. Just as an example, if I have this name property and I'm using JSON to store all of that, store the name into the data, in along with a person. So I'm using JSON to do that, right? So that gets stored this way as the first name. You can see the string here. So I'm persisting that additional information. Normally with the EF Core 5, if you wanted to be able to query that property, you couldn't do it because it expected text as that first parameter. And so now it's a lot easier to do that. So it's more flexible. And there, again, it's one of those things that a lot of people have asked for. Another EF6 parity. We can control the order of columns. They've been messing around with the defaults for the column order for a bunch of iterations. So now, if you need to, and we had this in EF6 also. I also just want to point out that if you aren't aware and haven't seen, the EF Core team has been really, really transparent. Not only, is all the code on GitHub, but they have their community stand-ups and all kinds of the stand-ups are like almost, I think, every other week. There's so many, they're amazing. And really, really detailed information about what's going on with the APIs. And also the team has been wonderful about highlighting all of the people who have been making contributions. So whenever they're blogging about it, they have this huge list that they're extracting. So that is it.
Sorry for interruption. I see this is almost last slide.
Yeah.
We are running out of time. I would like to discuss to invite all to discussion. Here we will continue the topic.
And just there's the links page. Yeah. Here's my contacts, and talk to you soon for an hour. Thanks, Anya.